So now today we'll see some good examples based on the height and distance. Let's take the first example. First write down the question. Question is a round balloon of radius r subtends and angle alpha at eye of the observer, while the angle of elevation of its center is beta. So prove that the height of the center of the balloon is r sin beta into cosec alpha by 2. So in the question it is given that there is a round balloon of radius r which subtends an angle of alpha at the eye of the observer, while the angle of elevation that the balloon is making is given as beta. So we have to prove that the height of the center of the balloon is r sin beta into cosec alpha by 2. So first thing we'll do is we'll see how to make the diagram for this and what will be the diagram look like. So accordingly we'll solve the question. So first we'll take the balloon and let's take this balloon. This is the eye of the observer. So a balloon is making an angle of alpha. This balloon is making an angle alpha at the eye of the observer, while the angle of elevation of this balloon, that is angle of elevation of the center of the balloon, that is let's take this is the center of the balloon. So the angle of elevation of the center of the balloon with the eye of the observer is given as beta. So it means this angle that the balloon is making with the eye of the observer is alpha, and this is the angle of angle of elevation that the balloon is making with the eye of the observer. That the center of the balloon is making with the eye of the observer. So this is given as angle beta. Now we have to prove that the height of the center of the balloon is r sin beta into cosec alpha by 2. Let's take this height as capital H. So we have to prove this, that capital H is equal to r sin beta into cosec alpha by 2. So how to start this question is let's take the balloon, the horizontal distance of the balloon with the eye of the observer, let's take it as x. So first we'll write down the question. First we'll write down the equation on the basis of this, and then we'll try to how to solve this equation. So first thing is this angle is given as alpha. So as this angle is given as alpha, and this is the center of the balloon. So if we drop if we drop the perpendicular to both these tangent, that is at the point A and at the point B of the balloon. So if we draw this, so there are these are the tangents at the point A and point B, which are actually touching these circles. And if we drop the tangent from the center of this balloon, this angle will the angle that that makes with the center of the balloon with the tangent is actually 90 degree. So now this as you see, let's take the center as O. Now as you see, and let's take this point as P, and let's take it as S. So now if you observe this triangle POB, so POB triangle is a right angle triangle, and on the basis of this we can write down we can use the trigonometry ratios and write down the equation. So first consider this angle. This angle is actually taken as alpha by 2, because this whole angle is alpha, and as we have drawn the line from this eye of the observer to the center, so that's why this line actually divides this angle alpha into two equal parts, and both parts will be alpha by 2. So if you write down the equation on the basis of this, what we'll write is, uh, let's take, we actually have to calculate, prove that the height will be equal to sine beta into cosec alpha by 2. So we'll start with the cosec alpha by 2 only. So if we write down the cosec alpha by 2 on the basis of this triangle POB, what we can write is cosec alpha by 2 will be equal to, as we know, the cosec is actually 1 upon sine alpha by 2. So to write down the value of cosec alpha by 2, we first have to know the sine alpha by 2. And if we consider sine alpha by 2 with this triangle POB, we'll get sine alpha by 2 as OB, that is perpendicular, upon OP, that is hypotenuse. So that it means the cosec alpha by 2 will be the reverse of this. So it will get as OP, that is hypotenuse, upon perpendicular distance, that is OB. And as you know that OB is actually the radius of the circle, so it means that the radius of the circle is actually the R. So cosec alpha by 2 is equal to OP upon OB, and OB is equal to R. It means the cosec alpha by 2 is equal to OP upon R. So this is the first equation we got. On the basis of this, now we'll write down the second equation, and in the second equation we'll take angle beta, and we have to prove that r sin beta into cosec alpha by 2 is the height of the center of the balloon. So we'll take the sin beta only, because in the proof we need to take the sin beta. So sin beta is actually equal to the OS, that is perpendicular distance, upon OP, that is hypotenuse. And so this is the sine beta, value of sine beta, and as OS we have taken as capital H, that is height of the center of the balloon, and OP is the hypotenuse. So these are the two equations we got. Now on the basis of this equation, now we'll try to solve it. So how to get that height is actually equal to the r sin beta into cosec alpha by 2. What we'll do is we will multiply first and second equation. So if we multiply first and second equation, we will get cosec alpha by 2 into sine beta is equal to OP upon R into H upon that OP. So now if you see, observe this equation that we got after multiplying these two equations, you will see that OP and OP will get cancelled. So we'll get here cosec alpha by 2 into sine beta is equal to height, that is H. H is actually the height of the center of the balloon, and divided by R. So now if we cross multiply, we will get as the height of the center of the balloon, that is H, is equal to R cosec alpha by 2 into sine beta. So this thing we have to prove on the basis of the given information. So accordingly we have proved this. So it is very important to actually make the correct diagram according to the given information, and on the basis of that we have to write down the proper equation. So if we have done that, it is very easier for us to solve the question and find out the value or the proof that we need to find out. So now we move on to the next question. Let's write down the next question first. The angle of elevation of a cliff from a fixed point is theta. So the angle of elevation of a cliff is given from the fixed point, that is theta. After going a distance k meters, that is capital K is given, k meters towards top of the cliff, going a distance k meter towards top of the cliff at an angle of phi, it is found that the angle of elevation of a cliff is alpha. So we have to prove that or show that height of the cliff is equal to k into bracket cos phi minus sin phi into cot alpha bracket closed whole divided by cot theta minus cot alpha meters. So this thing we have to prove. So in this question it is given that the angle of elevation from a fixed point to a cliff is given as theta. Now after going a distance of k meter, that is towards the top of the cliff, the angle of elevation is given as alpha. Towards the top of the cliff at an angle phi, the angle of elevation from that point is actually given as alpha. So we have to prove that the height of the cliff is k cos phi minus sin phi into cot alpha divided by cot theta minus cot alpha in meters. So how to make the diagram accordingly is, first thing, if you take the cliff, let's take this is the cliff and the height of the cliff we'll take it as capital H, and from a fixed point, let's say from the fixed point from the ground, the angle of elevation to the top of the cliff is given as theta. Now in the second part of the question it is given that after going a distance k meter towards the cliff, it means from this point we are moving towards the top of the cliff, and let's take this distance as capital A, and after moving a distance k, this is the point which is actually at an angle phi with the horizontal, and after reaching this point, the angle of elevation from this point towards the top of the cliff is actually given as alpha. So in this way we have to make the figure, and now we'll accordingly solve the question. So now how to solve it is, let's take this distance as A, and let's take this distance as B. Small a and small b. So now we'll write down the equation on the basis of the thing that we need to prove. So if you see that the thing we need to prove is that the height of the cliff, that is this capital H is equal to this thing, this given thing. So if you see that in this proof, they are using cos phi, sin phi, cot alpha, cot theta, and cot alpha again. So we'll write down the trigonometry. We'll use this trigonometry ratios to write down the equation. So first thing we'll see is cos phi. What will be the value of cos phi, or uh, uh, what will be the value of this cos phi? So cos phi, if you see, this is cos phi is equal to, first mark the points of the triangle, that is A, B, C, and let's mark this point as let's take P, and this point as Q. So if you see, the cos phi is actually equal to if you see the trigonometry ratio of the cos theta is actually equal to the base upon hypotenuse, and cos phi here is equal to the small a upon hypotenuse, that is k. This is the value of cos phi. Now the next thing we have to write out is the sin phi. Sin phi is equal to, sin phi, as you know, is equal to the perpendicular upon hypotenuse, and perpendicular, this, let's take this perpendicular as small h. So this sin phi is equal to small h, that is h upon k. Now cot alpha. So cot alpha is equal to, if you see in this diagram, that is pb, let's mark this point as s. So in the triangle pbs, so in the triangle pbs, cot alpha is actually equal to, the cot alpha, as you know, is actually the reverse of tan alpha, and tan alpha we know as perpendicular upon base. So cot alpha is equal to the base upon perpendicular, and base here is ps, that is b upon perpendicular. Perpendicular here is bs is capital H minus small h. This is cot alpha, and the next thing we have to write down is cot theta. Cot theta. So cot theta will be equal to the again a plus b upon capital H. This is cot theta. Now we'll see how we'll get the thing that we need to prove. So first thing we start with cot theta. So cot theta, as we know, is equal to a plus b upon H. And in this we need H, we need cot theta, but we don't need a and b. So we'll keep the value of a and b. And what will be the value of a and b is, if you see from cos phi is equal to a upon k. So we keep the value of a from cos phi, that which is equal to a upon k as, so we'll get the value of a as k into cos phi. This is the value of a we got, plus b. Now b here is, if you see in the cot alpha is equal to b upon capital H minus small h. It means we'll use this to replace the value of b, and value of b that we get from this is capital H minus small h multiplied by cot alpha, and this whole thing is divided by capital H. So this we got after replacing the value of a and b from the cos phi and cot alpha. Now again in the equation, the thing we got is we need cot theta, we need h, we need k, we need cos phi, we need this capital H, we need cot alpha, but we don't need this small h. So we'll keep the value of this small h from sin phi is equal to h upon k. So we'll got as cot theta is equal to k cos phi plus h cot alpha minus small h into cot alpha, and small h, instead of small h we can keep as k into sin phi into cot alpha whole divided by capital H. So now we'll cross multiply and solve this equation as, if we cross multiply we'll get as at h cot theta is equal to, and in the RHS part we'll take k common, so we'll get as cos phi minus sin phi into cot alpha bracket close plus h cot alpha. So this thing we got. Now we'll take this h on this h cot alpha on the left hand side of the equation. So we'll got as, so h will be taken as common, so we'll get as cot theta minus cot alpha is equal to k bracket close cos phi minus sin phi into cot alpha. So this thing we got, and now as we know that we have to find out the value of capital H. So the value of capital H is equal to k cos phi minus sin phi into cot alpha whole divided by cot theta minus cot alpha. So this thing we need to prove initially, that is asked in the question, that the height of the cliff, that is capital H, is equal to k into bracket cos phi minus sin phi into cot alpha upon cot theta minus cot alpha. So it is very important to make the correct diagram accordingly on the basis of given information, and with the help of this diagram we'll write down we'll use the trigonometry ratios, and accordingly we'll solve the equations using those trigonometry ratios.